Hello, welcome back to another video. Today we are going to be talking about Lewis structures. So Lewis structures are just a method of depicting molecules so that you and other chemists or people who are reading your work can understand what you're trying to say. So you've probably seen a Lewis structure. We'll draw some here in a second, but there's just some basic rules that we want to go over here. So at the top, you can see that these 5 are listed, and I'm sure you've seen this chart or some variation of this chart in your chemistry class. And you can obviously read through it. So you start by finding the total number of valence electrons. Then you pick a central atom. Carbon is usually the central atom if it's present. That's organic chemistry, which you'll take next year. It's never hydrogen because hydrogen can only bond once. We'll talk about that in a second. And it's rarely oxygen. And if you're not sure which one to pick, just pick the one that's the least electronegative. So electronegativity will be discussed in another video. So then moving on, you add valence electrons in either dot form or line form until you have completed all the octets. Hydrogen only needs 2, everything else needs 8. And you can do things like there are exceptions and there are incomplete octets and all kinds of exceptions that I'm sure you've touched on in class, and we'll hit on some of those. The one you'll run into probably the most is this multi-bonding down here. So you'll see that a lot with all of these atoms. So carbon, nitrogen, oxygen, sulfur are very common, especially in biological systems. So you'll see them a lot. And then the last thing to do, as always, is check your work. And then I put a note up here in the top right. So a line in a Lewis structure represents 2 electrons in a bond. So if you have an atom, we'll call it A, you can put an electron or 2 right there. And then you can draw a line to another one. And this line represents 2 electrons that are being shared by the 2 atoms. So that's what a line means. So remember, a line is 2. Something that's important is to find the number of bonds that an atom can make. And you start with 8, and then you subtract the number of valence electrons, and you get the number of bonds. The only exception to this is hydrogen. You start with 2. Start with 2 because hydrogen can only have 2 electrons around it. So for example, carbon has 4 valence electrons. So 8 minus 4 is 4. So carbon can bond 4 times. So that's, again, that's organic chemistry. That's why organic chemistry exists. And if you go on in chemistry, you'll take that. If not, then you don't have to worry about it too much. So I want to go through a quick example right now, following our rules. So if we look at this, carbon, we just know, has 4 valence electrons, so 4 bonds. And oxygen has 6 valence electrons, or 2 bonds. But there's 2 of those. So times 2. And that gives us a total of 16 valence electrons. So what we're going to do is start with the central carbon, because we know carbon goes in the middle. We're going to draw one line to oxygen on one side and one line to oxygen on the other. That's completely random. It doesn't have to be that way. It can be up and down. It can be side to side, whatever you want. And then we're just going to add valence electrons. So we know carbon. So remember, each bond is counted as 2 electrons that are shared. So carbon is sharing 4 electrons. So right now, carbon has 4. But we're going to start with the oxygen. So right now, each oxygen only has 2. So to get a full octet, we're going to add 6 electrons around each one. So now each oxygen has 8, and the carbon has 4, like we said earlier. So we're going to add 4 more electrons. Remember, electrons are added in pairs. So now we can count and check to see if this works. So we can see 2 bonds, so that's 4, and then 6, 8, 10, 12, 14, 16, 18, 20. So we have 4 too many. So we're going to have to add in double bonds. So to add in double bonds, we can erase a pair from the two atoms that are sharing the bond and add a bond in there. And then we can see we still have two too many. So we're going to erase again and add one more double bond. So now let's count. So carbon has 4 bonds, which is 8 electrons. Oxygen on the left has 2 lone pairs, so 4 electrons plus 2 bonds, that's another 4, so that's 8. The carbon or the oxygen on the other side is the same, so that's also 8. And we already said that carbon has 8, so we have the full octets. We have 2, 4, 6, 8, 10, 12, 14, 16. So we have the right number of valence electrons. Everything has an octet. We've checked our work and we're good to go. Hopefully that gives you a good idea of what's going on with a Lewis structure. I'll be back in another video to go through a little more complicated example. Thanks.